Okay, page 79. So we are looking at reflections now. Okay, we did reflections in the last chapter. We did one type of reflection in the last chapter. Anybody know what it was? Or remember what it was? Inverse. Yes, we reflected over the line y is equal to x. That's one type of reflection. There's two other types. Okay. Well, I guess there's more, but we're going to look at two other types. So we have the graph of x squared minus 10x plus 25, which looks like that. We're going to factor this because it's easier to deal with when it's factored. What multiplies to 25 and adds to negative 10? Negative 5 and negative 5. So it's x minus 5 all squared, which you look at the graph that they drew, makes perfect sense because what makes the inside 0 is positive 5. So we shifted the parabola over 5 units and it opens up. Okay. What does that negative right there do? Yeah, so you're multiplying the whole function by negative 1. Okay, so the equation is now going to be negative bracket x minus 5 all squared. What does that do to the graph? It makes it open down. All right, that's on the same. So it opens down like that. If you look at if you graph it on Desmos, there's Desmos right there. The blue one is the opening down. There's the functions. Here's the original. I'll put a negative in front. It just opens down. The only point that doesn't change is 5 and 0, the x-intercept. Okay? So, go back to this. The invariant points are the points that don't change. Invariant means it stays the same, okay? Doesn't vary. So the invariant point is 5, 0. In other words, the x-intercept. Okay. And you can see visually that every y value, so this is a y value of plus 5, becomes negative 5. You're basically just putting a negative in front of all the y values. All right? But this one right here is a y value of 5. All right, so we're moving on to x cubed minus 8. I'm going to put a negative in front of it. So the equation is going to be negative x cubed minus 8. If I multiply that negative in, what do I get? Negative x cubed plus 8. What does that plus 8 represent? The y-intercept, exactly. So the original had a y-intercept of negative 8. The reflected one has a y-intercept of positive 8. Again, it takes all your y values and dumps a negative in front. So if this has a y value of negative 7, it now becomes positive 7. And the whole graph just flips like that. This point stays the same because it's the x-intercept. Has coordinates 2, 0. That's the invariant point. So in word, yes, Noah?
So the invariant point is always the x-intercept then?
For this one, yeah. So in words, what does this negative do? Just tell me in words what it does. Flips it over the x-axis. Okay? So there's a couple ways to say it. So the negative there does a flip or a reflection across or you can say over, or sometimes the book will say about the x-axis. The thing that you need to remember is all y values have a negative put in front of them. That's it. You just put a negative in front of the y value. Does not change the x value. Only the y values change. Okay? So why do the x-intercepts not change?
It's the x-intercept, right? Because y is 0, and you can't have a negative 0.
Because y is 0. All right? Negative 1 times 0 is 0. So it doesn't change. All right? X-intercepts stay the same. Okay, so all your y values have a negative put in front of them, or you just remember it flips over the x-axis. So here's my graph. Sketch negative f of x, please. We done? Ready? Boom, there's the answer. Is that what we got? X-intercepts stay the same, so you just have to flip this point right here. Boom, and it opens up. That's it. May I flip the page, please? Going once, going twice. Boom. Here we go. So what do you think this does? It makes the x negative. It even basically says it right there in front of you. Negative x. Okay? So just to prove it, f of negative x, whatever's in brackets goes where in here? I just drew arrows at them. All your x's. So you get f of negative x is going to be negative x all squared minus 10 minus x plus 25. What's negative x squared? X squared plus 10x plus 25. Can you factor that? What's the factored form? X plus 5, or x plus 5 all squared. So, what makes the inside 0? Negative 5. And it opens up. And you can see it basically just flipped it over. Okay? It took your positive 5, we put a negative in, it just became a negative 5. So it flips it that way. In the previous example, when we went over the x-axis, the x-intercepts were invariant. Now we're going over the y-axis, so the y-intercepts are invariant. So the invariant points would be the y-intercepts, because what's the value of x at the y-intercepts? That's right. It's 0 and y. So if you're changing the x's and its value is 0, it has no effect. So do you feel like you could sketch f of negative x of this graph? Go for it. Sketching f of negative x of this graph. Remember, only the x values change. You're back. Do we have it? What we think is right, anyway? There you go. Is that it? All the x's became negative. So if this is at 2, it becomes negative 2. This is at, I don't know what that is. 2.5, it becomes negative 2.5. That's all. If you're already negative, it becomes positive. Okay? So the whole graph just goes like that. So, what do we say in words? What does this thing do? What's the fancy way of saying this? It's a flip or a reflection over what axis? Over the y-axis. Now, just remember, they can also say about the y-axis or across the y-axis. Basically, the x values become negative x. Just put a negative in front of all the x values, and you will get the graph. Oh, we should say the invariant points. Where do the invariant points occur? Invariance at the y-intercept, which is 0y, because x is 0. Okay. Sketch the graph of this absolute value thingy if we're doing this. Flip over the y. Please. Ready? You ready? You ready? Just gotta sketch that one. Just change all the x values to negative x. There it is. We get that? Okay. May I flip the page? What is this? It's our old friend. What is this? It's an inverse. What do you do to sketch the inverse? Whoops. Flip x and y. That's the same thing. I understand what you said. So you switch x and y, all right? So we're just going to do, let's do the middle one, okay? We're going to do this one. We're going to sketch the inverse of this function. See if you can remember it. See if I can do it. Sketch the inverse of that, please. Switch the x, y values. Nope, just the second one. Oh, we will, yeah. There's the graph, peoples. What are the coordinates of this point? 0, -8. Where does it go to? -8, 0. You just switch them. Does that make sense? Do we need to do another one? Or are we good? Do the bottom one then. If you want another one, do the bottom one. What's your question?
When you draw the shape,
Sorry?
when you draw like the line, like in the way it's graphed, it's like that with like a certain curve across it. How do you know when you write out the part where it's going to curve?
Just as long as it's the same general shape. Like, do you mean like where it goes through here?
Yeah, like that part.
That point is the y-intercept, so it's x is 0.
So when you chart that, let's say this is it, right? Like you got something like this, so it's always no matter where the y-intercept is, even if it's up here, like that.
Yeah, we haven't talked about what a cubic graph looks like yet, though, so I would give you the graph. Okay? What are we doing? We're doing inverse. -3, 0. -1, -2. All right. Do we have it? Does it look like that? If you're not getting it right, pick points, write them down, switch them, and then graph it. Don't try to do it in your head if it's not working. Yes, Constantine. How do I know? Well, I know. Okay, here's a trick. The original graph is this, right? It opens towards the negatives. Okay, it's facing down. So when you do the inverse, it should open towards the negatives. That's the negatives. Right? Negative x's. That's a trick. But if you plot the points in the correct order, you should still get the graph anyway.
So you just take like points from across, and you can kind of from where they are there, you can kind of like switch them across.
You switch the x, y values, yeah.
Switch my head with
1 to 4, please, people.